In this video, we're going to talk about how you can identify whether or not a relation is a function. But first, a word from our sponsor.
Look at this graph.
Thank you, Nickelback. Okay, so in this video, we're going to go through a few ways that we can think about how functions appear in these different forms, right? We've talked about the different forms of functions in graphs and ordered pairs and tables and mapping diagrams. And now I want to actually show you or kind of compare between things that are functions and are not functions. So let's look at this example right here. Look at this graph, right? Look at these graphs. One of these is a function, and one of them is not a function. So maybe think to yourself, what might be a function, what might not be a function? And how could you tell? Well, remember, a function, for each input or x value, there is exactly one output or y value. For each input or value in the domain, there is exactly one output or value in the range. So if I look at this graph, then if I look at this x value, and I know these lines can be kind of hard to see, right? For the x value -1, 2, 3, 4, I have the y value of -2. So if we were to write this as an ordered pair, I would say that that's -4, -2. And if I were to write this as an ordered pair, I would say that that's -4, 1, 2, 3. And then this up here looks like 1, 2, 3, 4, 5. So that looks like -3, 5. So here we can see I've got the same x value but different y values, the same input with different outputs. So this graph is not a function. This is not a function because I have an input with two outputs. Now, if we look at this graph, then you can see that here I have an x value of 1, 1, 2, 3, 4, 5. Over here we're at 4, 6, 7, 8. And over here we're at 5, 6, 7, 8. This looks like 8, 2, right? None of my, if you look at all the inputs, none of them have, none of them are the same, right? I don't have any of the same inputs. So as long as you don't have the same input with different outputs, you're good to go. Okay, let's move on. Look at this table. Now for these two tables, we need to think, what? Do I have one where there's multiple or the same input with multiple outputs? So let's check it out. Here, and you could write this however you feel comfortable. You could graph it or write it as ordered pairs or just leave it as a table. Since we just talked about ordered pairs, I might rewrite these as ordered pairs. So here I have 4, 15. I have 4, 0. I have 7, 13, and 18, -4. Again, look, I have the same x values with different y values. I have 4 mapped to 15 and 4 mapped to 0. That is no bueno, right? That is not a function. So this table is not a function. Let's look at this table. 15 goes to 17. 11 goes to -10. 14 goes to -9. And 18 goes to 12. 15, 11, 14, 18, those are all different. So since none of them are the same, I don't even have to worry about it. This is a function. Look at this mapping diagram. Okay, so again, we're looking for one value in the domain going to only one value in the range. not going to two values in the range. So we could write this as ordered pairs as well, right? 17, comma, 17 goes to negative 19. 10 goes to 8. 10 also goes to negative 5. So that right there, that should tell you all you need to know. I had this value in the domain mapped to two different values in the range. One input, two outputs. This is not a function. Versus this mapping diagram, 1 goes to 18, 13 goes to 3, and negative 19 goes to 9. Those are all distinct outputs for my inputs, all unique outputs for my inputs, not the same. Okay, now, what happens when I have a graph? Look at these graphs. Now, if you look at these graphs, it's just like with the dots, and you could even draw dots on these lines. So I don't know, right? Just is that more clear or that? I think this is a little more clear. So you could draw some dots along your line, right? And you can already see here, look, I've got dots. This is 1 about 2, and this is 1 about, I don't know, negative 3-ish. Same input, different outputs. Okay, if we look over here, again, I'm just kind of drawing a point on each. I'll kind of skip around a little bit, but you can see all of these different points, right, where they line right up. These are kind of nice, right? Here I have, this looks like negative 1, comma 2, and this looks like negative 1, comma negative 1. The same input, different outputs. Now you might notice something, maybe, I don't know. You might be noticing that if you were to draw a vertical line, that's almost vertical, where each of these points are, right, they would be connected, right, straight up and down. So we have what's called the vertical line test. It's an easy way to see if a relation is a function. If you have a graph like this, and you can draw a vertical line that goes through 2 points or more, it's not a function, because that would mean that we had the same input with different outputs. So let's try the vertical line test down here. Well, is there anywhere where I could draw a vertical line? So I could draw a vertical line over here, right? Oh, that only hits it, that only hits it 1 time. So that feels pretty good. But if I draw it right here, look, I'm hitting that function at 3 different points. So this is also not a function. Okay, what about this line? And hopefully this is a little more intuitive to you now, but if you were to draw a line, no matter where you drew a line, right? Doesn't matter where. No matter where you drew a line, it only hits the function 1 time. So while none of these are functions, because you can see the vertical lines are hitting twice, or the same inputs have different outputs, this is a function, definitely. So we looked at some graphs, we looked at some tables, some mapping diagrams, and hopefully this helps you get a better feel for what is a function and what's not a function.